folks, Mr. Reed here, and welcome to One More Question. So what we're going to do today is take a look at prime factorization, and we're going to do it at a medium level this time. So I'm going to take a slightly bigger number. My last example was 150, but I'm also going to take a couple of not as nice primes. They're still going to be relatively small in the grand scheme of things, but last time I just had 2, 3, 5, so going to make a stretch out a little bit more in this particular example. So if you want to do another prime factorization, you've come to the right place. Let's get to it. All right, so number above is 616. So again, I'm going to lay it out first time the way that I like to do it, and then I'm going to do it with a tree as well. So if I take the number 616, and I am just going to, beside it, write down prime numbers that go into it. And so we're going to be factoring out this 616 one number at a time. So first thing, it's even. I usually start with the small ones if I can. So since 2 is going to go into it, that's going to be 308 is what's left there. We're going to get another even value, so 2 goes into it again, so that's 154. And a 2 will go into that as well, which will be 77. So 77 is what's left there. And then I don't have a 2 that will go into it. Now, some of you might be screaming at me right now and saying, I know, what numbers are going to go into 77. But I'm going to do it kind of the tedious way. I'm going to start counting up all the different, or going through all my options, starting with my lowest prime number of 2, which obviously doesn't work. Okay, so 3. And so I might think about divisibility rules for 3. I might grab my calculator if that's something that's a little more comfortable to me. 3 does not go in. 5 does not go in. Doesn't end in a 5 or a 0. 7. 7's looking good. And so 7 will go into 77 11 times. And so 11's an interesting number because it's our first 2-digit number that we are going to end up stopping at. So this is prime as well, and we could test it if we wanted to, but I would suggest knowing enough about prime numbers that you recognize the 11. And if you didn't before going into this, I hope that you'll take the time after having seen this to get that 11, that 13, and go up as high as you think might be helpful to you. There is, it's not entirely necessary to, for instance, recognize that maybe 61, I think, is a prime number, but it can be helpful in some cases, but they would be pretty few and far between. All right, so that would be one way of doing this particular question. If I set it up as a tree instead, it's going to look like the following. So let's, sorry about that. All right, so 616 as a tree. So again, I might not, off the top, recognize anything that will go into a number this large other than the value 2. So it's actually going to look much more similar to my last example, or the other way I did this with the line. So these numbers here are the values that I came up with for my prime factorization. And this time, I'm going to end up seeing the exact same set of numbers because I really don't know 2 values that, other than 2, that's going to go into that. So then I get my 308. But anyway, there we go. And then 77 is going to factor into 7 and 11. So either way I do this, my final answer is going to be 2 times 2 times 2 times 7 times 11, or the same thing but written using a power instead. So 2 to the power of 3 times 7 times 11. And either way we write that, we've got an answer. So that one's a little bit more busy. You can, of course, have even larger numbers involved here. The method is going to always be the same. And if you are at any point uncomfortable with the values that you're playing around with, break out your calculator and just start testing prime numbers as divisors. So take your big number, divide it by the prime number you want to test, Do you get a whole number? If you do, it's a divisor. If you don't, you get some sort of decimal that happens after the whole number part of the answer, I guess. Then you're going to be saying, no, you're not going to divide in evenly, therefore I have to try a different prime number. I personally try to avoid giving you nasty larger primes that show up in these factorizations. So hopefully you'll get some practice in here and feel pretty good about things. All the best to you. So if you found that one helpful, like, subscribe, and as always, take care, folks.